with 4 vertices on the circumference. All right, what's your question? All right, let me carry on. For now, we need to listen. We need to listen. Right, so if you've got a quadrilateral, in this case, A, B, C, D, okay? If those 4 vertices are on the circumference, we say that the quadrilateral is cyclic. Okay, if you see a quadrilateral like this, okay, like that quadrilateral is not a cyclic part because this point is not on the circumference. So you cannot use the theorems that we are going to discuss just now when you've got a shape like that. The 4 vertices must be on the circumference. And cyclic parts are very, very important. In all examinations up to metric, there are questions on cyclic parts. So make sure you take this lesson very seriously, and the video that I made, you take it. You need that until you write metric next year. Okay? So I've explained this part, the concept of cyclic parts. Now there are three theorems on cyclic parts. Now the numbering of the theorem is not very important. The numbering of the theorem is not very important, but there are 3. For me this year, my 4th theorem was the first one under cyclic parts. It says angle subtended by a chord or an arc, okay, of the circle on the same side of the chord or arc are equal. Okay? So what that means is if you have a line segment AB, which is a chord, it has to be a what? A chord. Okay? A line which joins 2 points on the circumference. That line will subtend an angle at the circumference. In this case, it's going to be that angle. Okay? Furthermore, this line AB, or chord AB, it also subtends angle C. So this angle and that angle are going to be equal because they are both subtended by the same chord and they are found on the same side of the chord and they are also inside the same segment. Okay? They are inside the same segment. So this angle, we can call it ADB, is equal to angle ACB. Why are they equal? Well, they are angles subtended by the same chord. And they lie on the circumference. Okay? Also, if I choose, say, chord, if I choose this chord AD, it will subtend that angle, which is going to be this angle here, which is ACD. This same chord will also subtend this angle, which is going to be ABD, that angle. Okay? So you have to choose the chord and then you look at which angles are subtended by that chord. If those 2 angles are on the circumference, then you can say the angles are equal. Alright? So make sure you are aware of it. So, as a summary, when you are using the acceptable reasoning in the examination guidelines, this theorem 4, okay, sometimes it's called theorem 6, depending on the textbook, you just write angles in the same segment. And I explained to you what a segment is during the first lesson of this topic. Okay? We call this theorem 4 angles in the same segment. That's the shortcut based on examination guidelines. Okay? So, if angles are subtended by the same chord, on the same side of the chord, those angles will be equal. And we say they are angles in the same segment. When you are writing your reasons, you don't have to write all those stories. Okay? You don't have to write all those stories that I put in that bracket. You just write angles in the same segment. And then you are done. Okay? But if you get a question where they ask you to complete the statement, then you need to know the whole theorem in words. But usually that's 1 or 2 marks. But when you are doing calculations, you just write angles in the same segment. That's theorem 4. Okay? Now, theorem 4 also has a converse. Okay, remember what a converse is? No. It is a reverse statement of another. So it is the reverse of this theorem. This theorem says angles in the same segment are equal. Angles subtended by the same chord on the same side of the chord or arc are equal. Okay? Now, the opposite of that will be to say that if two angles on the circumference are subtended by a line by a line, therefore means that the line is what is going to be what? It's going to be a chord. Okay? So we are going to move on to the converse now. The video is there, so you should watch it and try and catch up. Okay? It's unfortunate that because of the situation we don't see each other every day. So you have to help me to help you. So it's two-way. Okay. So let's move on to the to theorem 4. Okay, the converse. Do you have any question? Me? Yeah. No. Okay, then sit properly. Go. All right. Now, theorem 4, the converse, says if a line joining 2 points subtends equal angles at other 2 points on the same side of the line segment, then these 4 points are concyclic. Okay, so if you've got two angles that are subtended by a line, if those 2 angles are on the circumference and the line joins 2 points on the circumference, we can say therefore the quad is cyclic. Okay? Now, this is very important because the converse, the shortcut is just write line subtends equal angles. So if this angle is equal to that angle, it therefore means that AB is going to be a chord, which means point A and point B will be on the circumference. Therefore, you can draw a circle around the 4 points. To therefore mean that you have a cyclic quad. Sometimes they can give you a shape like this one here, and they ask you to prove that ABCD is a cyclic quad. Okay? So they must give you the angles that they are equal, and then you need to prove that the 4 points form a circle. Okay? And the shortcut is line subtends equal angles. Now we can also write that as converse angles in the same segment. Now this, another way of writing is to say converse angles in the same segment. That's another way of writing line subtends equal angles. Right? Later on, we are going to learn about how to prove that a quadrilateral is cyclic. And you need the converse of a theorem for you to be able to do that. Okay? We use the converses to prove that a quadrilateral is cyclic. So, line subtends equal angles is the same as saying converse angles in the same segment. Alright? Any question there before I carry on? Theorem 5. The opposite angles of a cyclic quadrilateral are supplementary. The word supplementary means they add up to 180 degrees. So, if you are given a cyclic quad, like in this case, right, you have got that vertex, that one, and that one. All 4 vertices are on the circumference. Okay? So, if you add angle D and to angle B, you will get 180 degrees. The opposite angles of a cyclic quadrilateral are supplementary. Okay? Which means they add up to 180. Also, if you look at angle A plus angle C, if you add them, they also give you 180 degrees. The shortcut in terms of the reason is this one here. Okay, based on examination guidelines, you just write opposite angles of cyclic quad. That's all. You don't have to write the whole statement. Opposite angles of cyclic quad are supplemented. No, just write opposite angles of cyclic quad. All right. So that's theorem 5. Now, as I said, the cyclic quads are very, very important in this grade and the next year. Okay, they always bring a question on cyclic quads. And you have to know your 3 theorems of cyclic quads for you to be able to answer those questions. Alright? Then the proof now. Okay? The proof. The proof is examinable, which means it can come in an examination. They can give you a diagram and ask you prove that angle B plus angle D are equal to 180 degrees. You should know where to start. Okay? So when you want to do the proof, you use theorem 2. Okay? And your other knowledge of geometry. So the proof is examinable. And usually you have 5 or maybe 6 marks. And if you did not memorize it, you get a 0 for the question. And you come out and say the paper was difficult, but the proof you have got it in your book. But the proof cannot evaporate from the book into the head. Someone has to sit down and memorize it. Alright? So, first thing, to do the proof, you'll be given a circle like this one here, A, B, C, D. Then you need to create a radius. So you join point O and point A. You also join point O and point C. So you join those 2 points to form 2 radii. Okay? To form 2 radii, AO and OC. Then the next thing now, here at the center, you are going to have 2 angles at the center. You are going to have that angle which is going to be obtuse, and you are going to have that angle which is going to be reflex. Okay? So you have 2 angles. The first one, this one here, we call it O1, and that one what? O2. This is O1. Okay? Now we know from theorem what? 2. An angle at the center is equal to 2 times the angle at the circumference. That's theorem 2. I hope you are practicing on your own as well. Okay, I hope you are practicing. We did examples on theorem 2. Alright? So, angle O1 is equal to angle 2D. O1 is the angle at the center. It's equal to 2 times that. And our reason, theorem 2. The angle at center is equal to 2 times angle at the circumference. Alright? Then we again do it for O2. We say O2 is equal to 2B. The reason is also theorem 2. Angle at the center is equal to 2 times the angle at the circumference. Now, it's very important now to know what to do next. Right? Now, in mathematics, if you have got 2 equations like this, or 2 statements like this, right? You can add the left-hand side and also add the right-hand side. If you add the left-hand side, okay, the left-hand side, they are going to be equal to the sum of the right-hand sides. When you do that, you end up getting that equation. Okay? And that equation is going to be O1 plus O2 equal to 2D plus 2B. Then, you also know that if you add angle O1 and O2, you get 360 degrees because there are angles around a point. Okay? Then, okay, I simplified it here. So, O1 plus O2 is equal to 2D plus 2B. Then you say, but also O1 is equal to 360 degrees if you add O1 to O2. Right? Now, you see that here, the left-hand sides are equal. Therefore, the right-hand side will be equal. So we can write 2D plus 2B equal to 360. And then we take out a common factor, which is 2 there. We simplify, and then we'll come up with angle G plus angle B is equal to 180, which is that. Okay? Similarly, you can also do it for A plus C equal to 180 degrees. But for you to do that now, you need to construct a radii that is OD and another one, which is going to be OB. Okay, for you to be able to carry on. right? And then you come up with your equation. Angle D plus angle B is equal to 180. Right? Generally, they won't ask you both equations. They'll ask you one. So you need to know that first thing you construct your radii, and then you use your theorem 2 together with your knowledge of geometry from lower grades. Okay? So that proof, make sure you know it. So up to this point, there are three proofs that you are supposed to know up to this point. Theorem 1, line from center perpendicular to a chord bisects the chord.
So wait, let me write it down.
Theorem 2, okay, it's also examinable. Angle at the center is equal to 2 times the angle at the circumference. Theorem 3, okay, theorem 5, based on our work, right? Theorem 5, opposite angles of a cyclic quad are supplementary. Those proofs are examinable. We still have number 4, which we are going to do later when we talk about tangents.
So you still
Right?
that down and say,
Okay? I hope you can see what I wrote. I'm not talking about seeing the letters and stuff, okay, but I'm saying it. If you are going to sit down on a computer, you see what I wrote. Okay? All right. So, make sure you remember the converse. Right? Now, in a nutshell, if you compare the original theorem 5 and its converse, theorem 5, okay? Theorem 5 says the opposite angles of a cyclic quad are supplementary. That's theorem 5. So you'll be told that it's a cyclic quad, therefore the opposite angles are what? Are supplementary. The converse, you must add opposite angles. If they add up to 180, then you say that it's a what? It's a cyclic quad. If they don't add up to 180, then you say it's not a cyclic quad. So, theorem 5 and its converse are also related. Okay? So make sure you know that. Alright? So let me move on. Brother? Alright? If you draw a line from one of the vertices beyond the circumference, you create an exterior angle. Like in this case, the exterior angle is going to be that angle there, which will be CBE, which I can call what? B2. It's called an exterior angle of a cyclic quadrilateral. Okay? So B2 is an exterior angle of the cyclic quad. Now, based on theorem 6, an exterior angle of a cyclic quad is equal to an interior opposite angle, and that interior opposite angle is that. So angle B2 is equal to angle D. And your reason will be exterior angle of cyclic quadrilateral. Okay? Now, I went further because some books they don't show you where that comes from. Right?
just so why confuse us more.
So based on the diagram, right? This diagram here, if I write angle B1 is equal to angle B1 plus angle D is equal to 180, right? My reason will be opposite angles of cyclic quad. Okay? My reason will be opposite angle of cyclic quad, which is what? Theorem 5. Okay? Angle B1 is that, plus angle D, I must get what? 180. The reason, opposite angles of cyclic quadrilateral. Okay? Then, we also know from grade 8 and 9, angle B1 and B2, they add up to 180 because they are angles on a straight line. That's grade 8. Okay? That's grade 8. Now, since we have 180 here and we also have 180 there, it means I can add the left-hand sides. If I add the left-hand side, I'll get B1 plus D equal to B1 plus B2. Now, you can see that we have B1 here, we also have B1 there. Now, if I take this B1 to the left, it will cancel out with this one. Or if I take this B1 to the right, it will cancel out with that. So I'll be left with D on the left and B2 on the right, which means angle B2 is equal to angle D. An exterior angle a cyclic quad is equal to an interior opposite angle. Okay? And then we are done. Right? You must change your attitude. Alright. Let me carry. Says if an exterior angle of a quadrilateral is equal to an interior opposite angle, then the quadrilateral is cyclic. Okay? So if you are given a quadrilateral like in this case ABCD, and you have an exterior angle like C1 there. If C1 is equal to angle A, then you can say that ABCD is a cyclic quadrilateral. Therefore, points A, B, C, and D are found on the circumference of a circle. Okay? The moment you have a cyclic quad means you can draw a circle passing through those 4 points. Right? So, just to conclude, because for you to have a cyclic quadrilateral, the exterior angle must be equal to an interior opposite angle. To prove that a quadrilateral is cyclic, if an exterior angle is equal to an opposite interior angle, it therefore means that the quadrilateral is cyclic. So, this is Theorem 6, and that's the convex. Okay? So make sure you know the difference. Theorem 6, an exterior angle of a cyclic quad is equal to an interior opposite angle. The converse, if an exterior angle of a quadrilateral is equal to an interior opposite angle, it therefore means that the quadrilateral is cyclic. All right. So that's it there. So you've got 6